Either it's recording or I set the auto distract. So, day one, note one. What is our first notes going to be? We're going to talk just a little bit about science, what it is, what it isn't, anatomy, what it is, what it isn't. Anybody need notes? Paper for notes? Back for more. I'm glad you're here. So, what is science? What is a scientist? Basically, science is a process for answering questions. And I do want you to get that down. I do want you to take that as a note because that's what it is. A lot of people will give you a different definition. They'll say this, they'll say that. But for our purposes, we're going to say it's a process for answering questions. And what I want you to do, I want you to understand that to be science, we've got to follow the rules of science. If I challenge you to a game of basketball, you're going to show up wearing your shorts and your shirt and your sneakers, right? I come out wearing cleats, full pads, full birdcage face mask, shoulder pads, carrying an oblong ball. Are we going to be playing football or basketball? See where I'm going with this? You're expecting basketball. I'm not dressed for basketball, am I? Even no guy like me, I don't think anybody's going to want to go up under the boards with me wearing cleats. See where I'm going with this? I'm breaking the rules. If you don't follow the rule book, it's not science. What is the rule book of science? It's the scientific method. And I'm sure you've been hearing this for years. I remember encountering it in middle school. But let's review it just quickly. First step, if we're going to answer a question, we need to ask a question, don't we? So that's step number one. Ask your question. Not every question is going to be answerable via the scientific method. That doesn't mean your question is invalid. It just means science cannot be used to answer. Is everyone clear on that? Y'all want an example? Does caffeine consumption increase the risk of heart attack? Well, that's a good question, isn't it? That's one science can address, because we can test that, can't we? Y'all can steal my coffee. Y'all can tell I like coffee, right? I've got 2 mugs. It's just after 10 o'clock. What's your name?
Makaya,
You have a soul?
I suppose.
A soul. She doesn't know. I do. Where do you keep yours? Mine's in the right cookie. Now, is that something that we can test scientifically? No. You see where I'm going with this? What is a soul, right? Do we have one? Where does it reside? Those are questions that are still valid. Philosophy is built on questions like that. Theology, religion, you see where I'm going with that? And that's fine. They're simply not addressable using science. I want you to understand that science has its limitations. Step 2, propose a hypothesis. And since I have a fairly solid, heavy object in my hand, I'm not going to ask you what a hypothesis is. Because every time I ask that, somebody always says, "It's an educated guess." It makes me want to throw my coffee cup. What is an educated guess? I got me a PhD, so I'm educated, and I'm gonna guess you don't like this class. Makes it sound like it's uncertain, doesn't it? So we're gonna say a hypothesis is a proposed answer. It's not a guess. We have a very good reason for thinking that caffeine increases heart attacks, don't we? We know it's a stimulant, don't we? We know it interrupts sleep. We know it increases alertness. We know it gives you an energy burst. That's why we drink it. That's why you have places like Starbucks in business. So don't say it's an educated guess. Say instead it is a proposed answer that's based on prior knowledge. The third step is to test that hypothesis. We are going to conduct an experiment, aren't we? We're going to have a group that drinks coffee flavored water. They're the control. We're going to have a group that drinks 1 cup of coffee a day. We're going to have a group that drinks 2 cups of coffee a day. We're going to have a group that drinks 3 cups of coffee a day. You see what I'm doing here? I'm testing now. We have copies doing this. Then we're going to compare number of heart attacks. Everybody see that? This is an example of step 3, which is an experiment. In step 4, what we're going to do is we are going to analyze our data and we're going to draw conclusions from that data. We're going to analyze the data and we're going to draw conclusions. We're going to look at how many people suffered heart attacks. We're going to look at which groups suffered heart attacks. If people drinking 3 cups of coffee a day have more heart attacks than the people not drinking coffee, that's pretty good support for our hypothesis, isn't it? Everybody see how that works? Let's say it worked out differently. Let's say that the people who drank water had 4 times as many heart attacks as the people who drank 3 cups of coffee a day. That does not support our hypothesis, does it? Does everybody see how this works? Science never proves anything. All it does is mean that every single test we throw at that hypothesis does not nullify it. Every single test that we have come up with indicates that it appears to be correct. Does everyone see that? Yes or no? Thumbs up if you do. Thumbs up means this. Or at least look my way. Thank you all. That's just some little feedback. I learned that in the COVID year. I thought I was asking my students on Zoom to tell me if they got it, and they were giving me the thumbs up. Yeah, we did. Imagine my shame when I found out much later that that actually meant they like it. My students thought I was trolling them. Okay, so everybody with me? What's the last step of the scientific method? Communicate your findings. Let people know what you have figured out. If you don't do that, you might as well have not done it. Now, just a little aside here, you don't have to write this part down because I'm not going to test you over it. I just want you to have an understanding. Have y'all ever heard of peer review? Raise your hand if you have. Could anybody feel like you know it well enough to explain it? Don't feel bad. I was probably in graduate school before I really truly understood what the peer review process is. That's one of the reasons why I'm mentioning it. Here's what it means. After we've done our caffeine study, let's say me and Aiden did it. We write it up. We submit it to a journal. And what's your name again? Alyssa. Alyssa's the editor of that journal. She gets that manuscript, but rather than publish it, she sends it out for review. She sends one over here to Zizi, because you're an expert in the field, and one to Kara, who's an expert in the field. You read it. Does it sound like a good experiment to you?
Mhm.
So she says, yeah, publish. Kara doesn't like me. Does it sound like a good experiment to you? She says, don't publish. What do you do then?
Find another person.
Find another person. You said, over here to Lydia, who's also an expert. You look at it, and you say, yeah, he's right, this is it. But Kara's not wrong, because Smith and Aiden drew a wrong conclusion here, and they need to do another test. Then you send it back to Alyssa. You send it back to me. I'm a professor, you're a lowly grad student, I put you in and make you another 6 months on your dissertation. You revise it, we submit it back, then you publish. Everybody see how that works? Is Kara wrong to reject it? She has some valid concern too. Was Susie wrong to recommend it? She thought it was a good paper. Was Lydia wrong to suggest changes? That improves it. Because how many minds did we have looking at it now? You did the work, I got the credit, so 1. Technically 2, right? I apologize. Sorry. I thought I had turned that off. 1 minute, 2 minutes, 3, 4, 5. If all 5 of us have looked at it and reviewed it critically, is that going to be a good paper? Probably so. Science does not work like a democracy. It's not based on consensus. But peer review means that you've had trained, experienced people look at what you've done, evaluate it, and say, yeah, that's a pretty good approach. It looks to me like this is valid. Thank you all for letting me use these examples. I'm doing this, I'm trying to learn things. Is everybody clear on that? Now, a good hypothesis has to have 4 characteristics, and I do want you to write these down. Might be a good test question, don't you think? List and describe the 4 characteristics of a good hypothesis. Number 1, it should be an if-then statement. An if-then statement. If people consume increasing amounts of caffeine, then we will see an increase in heart attacks. That's a good hypothesis. It's an if-then statement, isn't it? Second thing is, it's predictive. Does it make a prediction? Well, ours just didn't it? We said as coffee increase goes like this, heart attacks are going to go like this, aren't they? That's our prediction. Third, it has to be falsifiable. In other words, we want that slope to look like this, don't we? Start here and go up. If it looks like this, that's the total opposite of what we expected, isn't it? That means we falsified it. And the last one, it has to be testable. In other words, we have to be able to come up with an experiment that examines the hypothesis. Does anyone need me to repeat that? Did I go too fast? Was it unclear?
I need you to go over 3 again, falsifiable. I need you to go over 3 again. Falsifiable.
Falsifiable. Thanks for catching me. Basically, it means that there is a way for you to prove it false. There is a way for you to prove it false. If gravity is real, then my cup will hit the floor when I release it. That's a good hypothesis, isn't it? Is that falsifiable? I'm asking you, Raven. Yeah, it is. We can test it. If it were to fly up to the ceiling or just float here, we falsified gravity, haven't we? Now, y'all are laughing at me because that's a ridiculous example, which is why I chose it. It could go down, it could stay here, it could go up, couldn't it? Now, we all know what's going to happen because we've all dropped things at some point in our life. Every single time you do that, you may not realize it, but you are testing a scientific hypothesis. Did you know that? Is that clear enough? Good question, by the way. If you're trying to prove something using science, you're never going to be able to prove it. All you can do is falsify it. If you can't falsify it, then you are as close to a fact as science can get. Is everybody clear on that? Now, I am going to throw another term out here. I do want you to go ahead and get this one down because it causes a lot of confusion. And that would be theory. That would be theory. A theory is a well-supported hypothesis. It is a well-supported hypothesis. Y'all okay with that? I'm not trying to insult your intelligence, but this is not a philosophy of science class, is it? We're just getting the basics here, and I just want to make sure everybody is comfortable with this. When I say something is theoretical, and I'm talking using everyday language, we take that to mean there is some uncertainty, isn't there? Theoretically, this is a good class. I don't know yet, do you? Y'all may think I'm a bad instructor. You may turn out to be bad students. We may both be bad. When we say that in everyday language, it implies uncertainty. In science, it's the exact opposite. A theory is as close as you can get to a scientific fact. It means every single test we have thrown at this hypothesis has not falsified it. Every single time we do an experiment, it comes out this way. Is everyone clear on that? Yes or no? Nod, drill, or otherwise. Show me that you get it. All right. Those would be some good test questions, wouldn't they? List and describe the 5 steps of the scientific method. List and describe 4 characteristics of a good hypothesis. Will that help you if I give you possible test questions as we go? I'll try to do that then. Did you have a question, Lydia? Or were you just flicking your hair?
Well, for theory,
Yeah.
I'm just trying to write down like what you were writing. I obviously.
All you have to put is a well-supported
Is that all?
hypothesis. That's all.
Okay.
I'm just wanting you all to get comfortable with the idea that a theory doesn't mean uncertainty. When a scientist mentions that something is a theory, they're basically saying that's as close to fact as we can get. Does that help? Because a lot of people get hung up, well, evolution's just a theory. Well, what does that mean? Well, it means that ever since Darwin published On the Origin of Species in 1859, people have been testing this idea. And every single time we test it, we come up with support for it. Does that help? Any other questions? Okay. Biology. What is biology? Comes from two words, and you don't have to write these down, it's just flavor. Bio, logos. Bio means life, logos means knowledge, the knowledge of life, the science of life. And specifically, within that area, we are going to be looking at one species and one species only. And that is the human species. When you look at any species, there's a lot of things you can do to describe it, aren't there? A lot of questions you can ask. If it's an animal, where does it live? How does it feed? How does it handle cold weather? How does it handle hot weather? What are its mating characteristics? What color is it? What size is it? You see where I'm going with this? Those are all physical traits, and we're going to be looking at physical traits of the human species, specifically the characteristics of the human body. That's what this course is about. What makes up a human? And we break that into two different categories: anatomy and physiology. Anatomy is the physical structure of the body. And by physical structure, I mean the fact that we have 4 limbs, not 6. Do we have wings? No. How many eyes do we have? 2. See where I'm going with this. The eyes are located on the front of the head, aren't they? See where I'm going? Location and structure. Form follows function. Form follows function. And by that, I mean the form of the structure dictates the function of the structure. What does the hand do? What's your name again?
Alyssa.
Alyssa. 2 Alyssas, this is going to blow my mind up. What's the function of the hand, would you say?
Like grab things.
Okay, grab things, yeah. Grasping, grabbing, it's good at that, isn't it? Can my foot grasp or grab things? Not really. I might be able to learn to use it, but the fact of the matter is, if I lost both my arms, I would be in for a rougher time. People who are born without arms can very often learn to use their toes and their feet in different ways. But you see where I'm going with this. The feet are not designed or developed or functional for grasping. They are functional for support. That's what anatomy is. Okay? Form follows function. Physiology is the chemical function of the body. What do I mean by that? Well, my favorite beverage, right? Coffee. You gotta ask yourself, what on earth was the first person to drink coffee thinking? Y'all ever seen a coffee berry? When I taught in Costa Rica, I actually lived in a house that was right in the middle of a grove of coffee trees. They looked like holly berries, but they're bigger. The bright red. Did y'all know that? They're not beans. What we call the bean is the seed. They have to take that off the tree, dry it in the sun or a heater. Then you have all these beans. Then you roast the beans. You have to roast them at just the right heat for just the right time. Then you grind them up. Then you pour boiling hot water over it and you drink it. What on earth was the first person to do that thing? Mentally irregular, I think. But why do we like it? Because it makes us have energy, doesn't it? It makes us more alert. It's a stimulant. Is that anatomy or is that physiology, Vanessa? Vanessa, sorry. See, I told you I was messed up. Is that physiology or is that anatomy? Physiology, good job. The interactions of that caffeine molecule with the cells in my body are what increase my alertness. Everybody agree with that? Around noon, my stomach's gonna start growling. Is that anatomy or is that physiology? Physiology, because I want energy, don't I? You see where I'm going with this? It's the interaction of the two. Both of them are equally important. Make sure you get that down. For the longest period of time, people have been curious about their bodies. And you'd be amazed at how many people don't know about their own body. Y'all want an example? True or false? People, meaning humans, can become resistant to antibiotics. How many of you think that's true? Raise your hand. Just about everyone. That's false. Oh, finally I get everybody's attention. I've been trying for an hour and 5 minutes. I'm glad I did it. Believe it or not, antibiotics in most cases have no effect whatsoever on the human body. Physiologically, we do not process, metabolize, or use an antibiotic. What happens is we are basically taking a selective poison to which we have immunity. However, the bacteria that were growing in the bones of my spine did not have immunity to that poison, thank God. Otherwise, I would not be here lecturing you today. Does everyone see where I'm going with this? And don't feel bad if you didn't know that. That's one of the reasons you're here, to learn. I'm not trying to get you trick questions. That is a question of physiology. Question?
So basically, it doesn't affect you chemically, but it affects your body, like your physical.
Believe it or not, for all intents and purposes, as to what happens to you, you might as well be drinking water as taking a pill. You get no energy from it. It does not harm you. It does not have any effect on you whatsoever. Y'all did not know that.
So the medicine is just fighting it's literally, obviously, just for the infection, is what you're saying.
Bingo. It kills the bacteria. Now, you may get side effects. If you've got a very nasty infection and you take really strong antibiotics for a really long period of time, you may get diarrhea, right? The reason for that is because the antibiotic has not only killed off the bad bacteria, it's killed off the good bacteria that live in your gut. But it has not affected your stomach, your small intestine, or your large intestine. Everybody clear on that? Good question, wasn't it? Don't ever hesitate to ask anything in here, folks. You're not stupid. This is how you learn things. I hope I would know a little bit more than you. I've been doing this for quite a few years, and I've got a PhD in it. It'd be kind of bad if I was teaching the class and I didn't. So everybody cool with that? Y'all want another strange one? True or false? If you have a viral infection, an antibiotic might help you. How many say true? How many say false? The rest of y'all look like you're in Congress. Yep, the bill's gonna pass. Throw up that vote at the last second. Good job. Viruses are completely unaffected by antibiotics. That's why when you get the flu, they don't prescribe you an antibiotic. Now, can a person be allergic to an antibiotic? Yes, absolutely. When you take an antibiotic, you are taking a foreign substance into your body, aren't you? Your immune system basically recognizes self or non-self. If it's self, that means it belongs here, doesn't it? If it is non-self, does it belong? It's an invader. Kill it. Can you become allergic to anything at any time? Yes. For years, I worked in a research lab, and I wore gloves every day. Back in the day, we used latex. If I were to put on a pair of latex gloves now, my wrists where the gloves meet the air would break out into hives within 5 minutes. I've developed an allergy to that. When you're putting something into your body that's not been in there before, there is a chance your body will recognize it as non-self and it will start attacking it. So can you be allergic to antibiotics? Absolutely. It's a foreign chemical. Your body says this doesn't belong here and it starts attacking it. In fact, a lot of toxins, things like snake bites, for example, they give you anti-venom. Those are actually antibodies against the venom. Did y'all realize that? So they bind it up like your immune system would do and neutralize it. And hopefully in the process, it doesn't kill you. Anybody here ever heard of the Spanish flu? 1918, there was a massive flu outbreak. It was probably the worst pandemic in human history. Killed upwards of 100 million people. Put that in perspective, that's a third of the population of the United States today. Now that was worldwide, but obviously the population of the world was a lot lower at the time. What killed most of the people was not the influenza, the actual viral infection. It was the hyperimmune response of people to it. They essentially died from anaphylactic shock. So I apologize for the little rabbit path we took down there, but I think it was worthwhile and interesting because I think it did a good job illustrating to you all the difference between anatomy and physiology, doesn't it? Antibiotics don't affect your physiology, do they? Everybody see how that goes? I'm a type 2 diabetic. That means my body does not respond to insulin. What's your name again? Sierra. I pick on everybody, so don't feel bad. If I haven't picked on you yet, I will. Sierra, is type 2 diabetes anatomy or physiology? Is it a structure or physiology? Yeah. See how I'm trying to get you guys thinking this way? Most of what we're going to learn today is going to be anatomy. Most of what we're going to learn in this class. But I want you to keep in mind that form follows function. So the physiology part is always going to be lurking there in the back. Is everybody cool with that? So to review what we talked about today, give you a 2-minute review. Everybody okay with that? Everybody knows how to access the course online. Everybody was able to access the syllabus, right? Nobody was able to access the registration, of course not. None of that's going to be on the test. What will be on the test, you need to know the definition of science, the definition of theory, the steps of the scientific method, the characteristics of a good hypothesis, definition of anatomy, definition of physiology, how to tell the two apart. Does that little roundup help you guys? Want me to continue doing that? Okay. Haley, you have a question?
Repeat that one more time, please.
Sure. Which part?
I got science, theory, steps of scientific method, and then I didn't get the.
Okay. Characteristics of a good hypothesis. Definition of anatomy. Definition of physiology. And how to tell the two apart.
Thank you.
You're quite welcome. All right, I believe that our time is now drawn to a close. Are there any gripes, complaints, comments, cogitations, observations, ruminations, or insinuations?